Hello and welcome back, everybody. In geometry today, we will look at the idea or concepts of the arcs and also central angles inside a triangle. So the last thing that we looked at would be the tangents of a circle, and then we're going to come back to that in a little bit because I want to introduce, I guess, this part which is going to tie up to that tangent, and then you can see the big picture as a result then. So just a few more definitions that we need to introduce, and then afterwards, like I said, we're going to go ahead and put them all together. So for today, we are going to, as we said, look at the following right here. So we're going to define what is a central angle, what is a major arc, what is a minor arc, and then the semicircle. In addition, there is also the arc addition postulate or theorem, depending on which textbook you're looking at. And finally, theorem 7.3. Okay, theorem 7.3. So that one's kind of strange out there, right? But anyhow, so here, let me kind of show you the bottom picture right here, and it'll define everything that we need to. And I'm going to go ahead and make my pen a little bit smaller, if it's okay. So the definitions that we are going to define, all of these guys right here, can be best described on the right-hand side according to the picture that's on the left-hand side. So note on the left over here, we have a circle where the center is going to be at some point, we're going to go ahead and call P. A is going to be a point that's on the circumference of the circle. And then B is also going to be another point that's on the circumference of the circle. And also W is going to be another point that's on the circumference of the circle. So we are going to define the following then. If we ever refer to the central angle of the circle, then that means it's in this picture, the angle APB. So meaning that two of the points are going to be on the circle, the circumference, and then P is going to be the center of the circle, and hence that's why it's called the central angle. Now, in addition to that, there is something called the minor arc. So the minor arc is referred in this picture as AB, the arc over here. So you can see that from here to here, that's what we call the minor arc. And anything that's a minor arc, the measurement of it, there is a numerical value that we refer to, and that measurement is supposed to be less than 180 degrees, because as you can see, the arc that we're referring to is related to the central angle that I was just talking about. Now, for something that's called a semicircle, that is going to go from B all the way to W, and this is assuming that WB creates a diameter. Okay, so WB right there has to create a diameter in order for this to be a semicircle. The measurement of this semicircle is equal to 180 degrees, and once again, you can see how that is related to the central angle right there. So, for example, as I was saying earlier, let's say that AB right here, we can denote it as 50 degrees. And that right then would then be the same as the central angle, which is 50 degrees. Whereas for the semicircle, you can see that the angle between WPB over here is going to be 180 degrees. And so that means that this guy right here, the entire arc, is in referencing to the 180 degrees that I was just talking about. So in essence, what that means is that the central angle and the arc angle are one and the same. And that right there is going to be your theorem 7.3 in this case then, okay? Not much of a theorem, I guess. It's more like a postulate in a way because there's really nothing to prove. But anyhow, keep the ball rolling. The next thing that we're talking about is something called a major arc. And the major arc is going to be something that is greater than 180 degrees. Now, in terms of where is it in this picture, it's going to be from A to B, but with W in between them. So that means here is going to be A. So notice that if I go this way in the rotation, that A and then include W and then B right there, that right there will then be considered a major arc then. Okay, so as I said before, it is a measurement that is always greater than 180 degrees. And you can see it actually inside the angle, the central angle, because your rotation is going to go from A all the way to B. So you can see how that's greater than 180 then. Well, the conclusion about the two, or the relationship between the major arc and the minor arc, is that, well, the sum of those two would then be equal to 360 degrees because you're going at a full rotation. If the semicircle is 180 and then you're going to add on another semicircle on the bottom, that only makes sense that it's 180 plus 180 is equal to 360 degrees. All right, so that is basically the idea behind all of these guys right there. So those are the definitions that we're looking at. Now let's go ahead and look at something called the arc addition postulate or theorem, depending on which book you're going to look at. So here in the picture, it says that, hey, if you have any two arcs and you want to add them up, the result is just going to be the bigger arc. This right here is pretty much similar, if not almost identical, to the segment addition postulate and also the angle addition postulate. Now, remember that for the angle addition postulate, you have to make sure that those two angles are right next to each other. That one of the they both share a certain side in order for them to add together. Over here for the arc addition, it's exactly the same thing. In order to add AB, which is located right here, with BC, which is located right here, B has to be kind of like the little in-between connector between the two then. And that would then give you the arc ABC. Also, something that I did not mention earlier, it's preferable that you would write each of these arcs with 3 letters if possible, because then we can be a little bit more clear as to which arc you're actually referring to. Because if I were to write the measurement of AC, right, as an arc, some people might think, oh, then that means we could possibly be referring to this part over here. So that is some sort of like, something that we want to clarify if possible. 99% of the times when you're writing an arc with 2 letters, it's always referring to the minor arc. So let me repeat that one more time. 99% of the times when you're writing the arc using 2 letters, it's always referring to the minor arc. So meaning it's the one that is less than 180 degrees. But, some people might say otherwise. So, just for safety reasons, a lot of times people want to, if possible, use 3 letters for this one. Okay. All right, but anyhow, so for this theorem right here, like I said, some in the Moise book, this is considered a theorem because you can actually prove it. But whereas in the Jergensen book, this is considered a postulate because, well, he doesn't want to prove it. It is actually provable, so it's actually going to be something really quick, and we can go ahead and get that out of the way right now. Because, me, I like to prove things then, because I don't want to just go ahead and give it to you blindly. So the way we're going to do it is we're going to go ahead and look at this equation right here and rewrite each one. The measurement of AB over here, right? According to my theorem over here on the top earlier, the measurement of the arc AB, that is going to be the same thing as the measurement of APB. It's going to be this angle right here. If you want, we can go ahead and call it X right there. Okay, so that's going to be angle X right there. Okay, or angle of X degree. Then next one over here, the measurement of BC, that is going to be the measurement of BPC. Just again, referencing the central angle. So if you want, we can go ahead and call that Y. That's over there. Now, looking at those two, if you add them together, that is going to be equal to the measurement of APC, which is the whole thing, right, from here all the way to here. Or if you want, measurement of X plus measurement of Y. And now that concludes to going backwards as the same thing as the measurement of arc ABC. And so there is your proof then. Okay, pretty short for the most part. All right, now let's go ahead and take a look at some problems right here, and then we'll go ahead and call it a day afterwards. You can see that I stole this from a textbook because the right-hand side, well, my picture, it looks kind of weird then in that case. But anyhow, nonetheless, let's go at it. The 2 points on a circle determines the minor arc and the major arc. So if the minor arc is supposed to be, if the measurement of the, let me go ahead and underline it. If the measure of the major arc is 40 less than 4 times the measurement of the minor arc, find the measurement of each arc. Well, let's go ahead and draw a picture because that's always a good place to start. They tell you that you have 2 points that are going to determine the major and minor arc. So that means it's going to be this guy over here, and it's going to be this guy that's over here. All right. So now let's go ahead and denote each one. They're saying the minor arc, and I think this is where we introduce a variable. It might be kind of helpful, right? If the measurement of the major arc, now we're looking at this part over here, is equal to 4t less than 4 times the minor arc. Okay, 40 less than 4 times the minor arc. And there you go. That's going to be this part over here. Well, looking at how we were supposed to approach this from before, the total sum of the measurement of the whole revolution, minor plus major, should equal to 360 degrees because it's a full revolution. So I can then say x plus 4x minus 40 is then equal to 360 degrees. So clean up the algebra. 5x minus 40 is equal to 360. 5x is then equal to 400, so therefore x is equal to 80. So that right there is going to be my minor arc then. Okay, so that's going to be my minor arc AB. Whereas for the other one, well, then that means it's going to be 360 minus 80. So the major arc, okay, so the major arc of AB, and notice how I'm being specific at each one so you know which one's which, is going to be equal to 360 minus 80, which equals to 280 degrees then. So there are your two solutions, all right? And finally here, let's just look at this one last one. This one should be pretty straightforward, hopefully. Let's see, if I'm given this picture right here, I want to find the measurement of JK. So over here, that's going to be my measurement. Well, knowing that H and K over there, actually assuming that H and K over there are diameters, then that means that the total from here to here should be 180. So if I take the 50 and subtract it, then that means that's going to get our answer. So 180 minus 50, that is equal to 130 degrees then, okay? And again, this has to be on assumption that HK is going to be the diameter, which I think should have been written actually. And finally, for the last one, HJK, so HJK, HKJ, my fault, HKJ. So that means from here all the way to K, all the way to J, so that's going to be this guy. Well, then that means you're going to be using something similar to what we just did earlier, which is going to be 360 degrees, the whole thing, minus that minor arc of 50 degrees. That makes up HJ, and that would then be equal to what we want, which is going to be the measurement of HKJ, which is 310 degrees. All right, there you go. Thank you so much for watching, and I will see you guys next time then. Have a good one. Bye-bye.